So I'm going to use this segment to discuss using Excel to do numerical calculations and expressions. I cut and paste this image from elsewhere just to keep track of the formula that we're actually trying to replicate here. So what I'm first going to do is use the cells in Excel to fill up values that I will actually use in the expression. So we're just going to get started by doing it. I'm going to use column row as kind of a description. So what I'll say here is let's go ahead and fill this in. Let's just say Q. Let's say I'll type in the letter Q, and let's do this. I'll say variable, or I'll say quantity. This is like a title. So the quantity, and then I'll say description, maybe description. Okay, so our first quantity will be, and let's say value. One more. And if I can spell it right. Okay, so the quantity will be Q. The description will be charge, and I want to give it a value of 1. And now let's start putting in these constants. I'm just gonna fill the value in, so I'm gonna hit number 4. Over here, I'm going to, I happen to know that to get the number pi, we can use this function. I'm gonna say equal pi open parentheses and close parentheses. And if you'll notice what happened, just by saying equal to this empty argument function, it knows to return the value of pi. And hey, that's just a feature of Excel. And I don't know how to describe it any better than that. So I could have just typed in the number for pi to whatever decimal place I wanted. I'm going to put the free space. I don't think this constant is available. So I'll say, let's just call it eps naught. Eps 0, it's just a description. We know what that is, and I'm just going to put the number in directly. I'll say 8.854 E negative 12. Okay, and there's no evaluation that needs to be done there. It does put it in the decimal form, though, but even though it shows it to me in scientific notation. So the idea is that these are all going to be things that are going to be unchanging, whereas the distance, r squared, will be changing based on the values that I'm about to feed it. So what I'd like to do now is I'm going to I'll just put a little frame around these, and I'll know that you can use these little borders, and I'll know that these are kind of my static values. What I'd like to do now is I've got a separate section here, and I'm going to make this distance. So I'll just give it the title, distance. And this is going to be, distance. And I'll do this as a function of r. So I'll distance r. So I'm going to start with I'm going to start with 1 millimeter. Now, if you remember from the previous discussion, we know that we want the units to be in meters. So when I ask for 1 millimeter, I may as well type it in actual meters. So 1 millimeter is actually 0.001. And what I can do is say, let's make a plot. Let's make a plot. Let's anticipate a plot that has values going from 1 millimeter up to a meter. Those are the calculations that we did earlier. Well, you can see what I could possibly do is just start filling in these numbers in the cell manually. A neat feature of Excel, though, and certainly we could do this even better in macros. But if you notice what I did, I grabbed the first 3 values that I put in here, and you'll see this little handle that pops up. And when I hover over that green looking square handle, as I start to drag it down, you'll see that Excel kind of applies a little bit of its own understanding as to what it thinks I want to do. And based on that trend and that history of the first 3 numbers, it correctly decides to just go ahead and add numbers to it. So this is extremely handy. There are these autofill options. I'm not going to get into any of these right now. Maybe we'll come back to that at some later time. But you'll notice now, as I continue to drag, depending on which grouping I choose, I should be able to continue to fill up, up to 1,000. And it's still a manual process that I'm choosing, but it's pretty easy to scroll down until I get into the thousands, right about here. I think I was about 8 rows down, maybe. So once I get to about here, it looks like I guessed properly. I was 1008. And you've seen that I've just created rows of, I created, let's just say, a column of position data from 1 millimeter all the way out to 1 meter. Over here on the right, I've got this scroll bar that I can get myself back up to the very top of the spreadsheet. And what I want to do now is, let's say, match. So I just filled in R. What I'd like to do in this column is, let's say, mag E. Let's just call it magnitude of the E field, okay, for a distance of R. So now, much like what I did in this first column, I'm going to start typing an expression that I want, and then I'm going to replicate it by dragging that handle. So let's type in what this formula is. So we know that mag E is represented by this, and I just put all of those values either somewhere in this frame up here as constants, or as the variable, as discrete positions of a variable. So I'm going to put the expression in by typing equal sign first, and then now I'm going to point to cells to start filling things out, and I'll probably come back and add parentheses and brackets as needed. It's waiting for me to grab the very first value. I'm going to choose the numerator, which is the charge, and it's represented by that value. And you'll see, not only does it give me, a color, it actually refers to the cell. So the cell is in row C, or I should say column C, in row 2. If I happen to click here before I approve it, you'll also see that the colors are lining up, right? So the blue, when I click in this cell, is represented by this blue color here. So that doesn't give us much information right now, but as we add values, you'll see that's going to change. So as you may have guessed, if I want to divide, I'm going to hit on my keyboard the / symbol. That looks like that. And now I'm going to multiply these values together. I'm going to come back and add the parentheses in a second. So let's multiply 4 times pi times epsilon naught. Well, that's nothing more than just choosing 4. And now I'll hit the asterisk, which is above number 8 on my keyboard. And then you'll see that it's going to wait for me to select another cell, and there it is, C4. I'm going to do it one more time, asterisk again, and then I'm going to choose the epsilon naught value. So there it is. That's Q over 4 pi epsilon naught. The next thing I want to do is choose my R value and square it. So I'm going to hit multiply again. That's the asterisk. And then I'm going to click on the very first value. So A9 is my radius for this first row. And the last thing I want to do with this is actually square it. So the square function is done by what we call the caret. If you look at your keyboard at number 6, you'll see right above it, by holding the shift function, I see a caret. The caret means raise it to the power that's coming, and the power is going to be 2. And I'm going to hit enter. And you'll see I get a value, but since I didn't take the time to get my order of operations defined with parentheses, this is actually not the correct value. So I had intended to do it this way because now I can come back and add the parentheses. So what I want to do is make sure that I group all the constants. So there's a left parenthesis, and right after C5, I have a left and now I have a right. So I'm closed out, and the next thing that is going to get multiplied is going to be, it's going to get multiplied by this A9 squared. So it's probably another good idea, and I can verify this later, is to make sure this entire expression gets considered to be in the denominator. and I'm carefully putting the bracket around everything that is supposed to be in the denominator. So the parentheses should keep the constants from being squared, and the brackets should ensure that the constants are going to be multiplied by the variables squared and kept in the denominator. And I believe that's going to work. And I'll hit the check mark, and it doesn't like the syntax. I must have forgotten something. Let's see here. So what I think I just found from trying to troubleshoot this is that it doesn't, Excel appears to have a syntax error when I change from parentheses to brackets. So I thought I was being clever by trying to keep things organized, but instead let's just use parentheses for all arguments. So this is what I thought I was doing the first time, and I'm gonna hit return, and it appears that I get a good value. So actually, if you go back and check, you should be able to verify that that's really close to the same number that we got for the 1 millimeter calculation that we did analytically earlier on. Now let's see what happens when I try to drag this handle that represents all of this stuff up here in the function, and let's just drag a couple of rows. And we don't get very far. We get this divide by 0, some weird message. I guess it probably tells us exactly what's going on here. So if you look, if we click up in this function tab, or in the function field, it tells us exactly what cell is involved in the calculation. So all of a sudden my C4 is no longer the value 4. It's actually shifted down 1. Same with C5, C6. There were supposed to be these first 3 numbers, and the cells have all taken a shift down. So the same thing is going to happen when I look at this. Sorry, let me hit escape. Every time you hit escape, it brings you out of the argument mode. But as I go through these cells, you can see the rows have all shifted down 1. Really similar to what's happened with the distance. So the problem is I don't want those rows to shift down. The only ones that I want to shift down is this A row. So that's my variable. The other ones are constants. So if I delete these values, and let's go ahead and try this over again. I know that with Excel, one way I can lock a row or a column is to put the dollar sign in front of the respective part. So what that means is, let's say C3 right now is the integer 4. I want that to stay in place as I repeat this calculation. So the column is not going to shift, but I know that the row is going to shift. So the row takes place at the number. So I'm going to insert a dollar sign in front of that number. I'm going to do the same thing for C4. That was my value of pi. I'll put the dollar sign in. And then I'll do the same thing for C5, which is my epsilon naught. And now when I hit enter, I'm going to go ahead and click the cell again, and I'll drag that handle a couple of rows, and let's see if it appears to be doing the right thing. So there's my first value. As I step down, I can see, as I just kind of toggle between a couple of cells here, the only thing that appears to be changing is column A, and that's my distance. So that's great. I've got all constants, including my charge, and I'm only varying the R. So now what I'll do is I'll go ahead and grab a block of 4 of them, since they're all correct. I'll grab that handle, and I'll just drag it until I get to 1 meter. And there it is. And I'll see them all fill in, and you'll recognize that number as well. 9E9 was very close to the value that we got for our analytical calculation of the point charge of the field of the magnitude of the field of a point charge at 1 meter in distance.